Hello guys, I hope you're all doing well. Welcome again to my channel named enginiusmechtech. As we are started our chapter or top our book Fundamentals of Manufacturing Processes, we are here on our next chapter, that is chapter number 10 on our book. It is lecture number 2. It is lecture number 2 of the course Manufacturing Processes, and the chapter name is Fundamentals of Metal Casting. Today we start the casting of metals. That how we do. There is a small overview of casting technology, how to heat, how to pour the metal, solidification and cooling. All the things are included in these. All the things are included in this lecture. Solidification process. Starting work material. When we start this process, the starting material is in the form of a liquid or in the form of highly plastic condition that can flow, and a part is created through the solidification of metal. Then this molten or highly plastic metal or material is solidified to get the material. Solidification process can be classified according to engineering material process. Metals, maybe ceramics, maybe polymers, and maybe PMCs, polymer metric composite. I hope you have done your assignment about polymer matrix composite. Yeah. Solidification process is divided into casting of metal, glass working, processing of polymers and PMCs. Casting of metal is divided into expandable mold casting, permanent mold casting, and then it is also divided into sand casting and other casting. And processing of polymers and PMCs, extrusion and injection molding. We will discuss it later. Now we move toward our main topic, casting. Basically, casting is a process in which molten metal flows by gravity or any other force into the mold, where it solidifies in the shape of the mold. The term casting also applies to the part made in the process. The steps in casting seem simple. First step is melt the metal. Second step, pour it into a mold. Definitely you need some shape. There is some desirable shape. You made the mold for your desirable shape, then pour the molten metal into the mold and let it to freeze. However, there are many factors and variables must be considered to accomplish the successful casting operation. Let's move. Ingot and shape casting. The term ingot is usually associated with the primary metal industries. It is basically the raw metal. It describes large casting that is simple in shape and intended for subsequent reshaping process. There is the raw material, such type of long bar. Then it is cutted or machined, or there are some different processes such as rolling or forging to change the shape. And shape casting involves the production of more complex geometries. We can make complex geometries with this shape casting because there are some cores and other terminologies. We discuss it later. That makes the part much closer to the final desired shape of the part or product. Parts made by casting. There are big parts that are made: engine blocks, head for automotive vehicles, wood burning stoves, machine frames, railway wheels, pipes, church bells, and pump housing. And there are also small parts, including dental crowns, jewelry, small statues, and frying pans. All varieties of metal can be cast, ferrous and non-ferrous. There are some advantages. Everything has some advantages and disadvantages. Let's see. Capabilities and advantages of casting include: it can create complex part and geometries, can create both external and internal shapes. Some casting processes are near net, others are net shaped, can produce large parts. Some casting methods are suited for mass production, can be some casting methods are suited for the mass production, can be performed on any metal that can be heated to a liquid state. There is no limitation that you can do casting for steel, but not for there is no limit that you can do casting for aluminium, but not for steel. If you have environment that you can raise temperature of steel to its molten state, then you can do casting. There are also some disadvantages. Different advantages for different casting process. Limitation on mechanical properties. You cannot control the desired mechanical properties due to presence of defects in properties. Also, there is some dimensional disaccuracy, inaccuracy. The surface finish or some processes also not good surface finishing. For example, in case of sand casting, there is not good finishing. Also, there are safety hazards for the workers because there is molten metal on high temperature. It can also harm or damage the skin of a worker. Also, some environmental problems. Overview of casting technology. Casting is usually performed in a foundry shop. Foundry is a factory equipped with making molds, melting and handling molten metals, performing the casting processes, and also for cleaning and the finished casting. Workers who perform casting are called foundrymen. The casting process begins with the forming of molds. First of all, you need to make molds in which you pour the molten metal. Then molten metal is poured in the mold which is cooled down and solidified. Further processing such as trimming, cleaning, heat treatment, machining may be required. The mold in casting. The mold contains a cavity whose geometry determines the part shape. For example, you make a mold. There is specific part that is part. There is a cavity in which the metal flows and may give you the part. Actual size and shape of cavity must be slightly oversized to allow the shrinkage because it is a metal. When it solidifies, its dimension decrease. So for to cover that decrease in dimensions, we make some oversizing, some allowances. Molds are made of a variety of materials including sand mold, plaster mold, ceramic mold, and metallic mold. Open mold are simply a container in the shape of the desired part. There is no closing. Closed mold in which mold geometry is more complex and are required gating system. There is this gating system. This gating system. This pouring cup, riser, and this is the desired part. This is the way. There are two categories of casting processes: expandable mold use and expandable mold. Mold material includes sand, plaster, and similar materials plus binders that sticks the sand. Permanent mold process use a permanent mold which can be used many times to produce many castings. Mold of metal or less commonly a ceramic refractory material. Relative advantage: more intricate geometries are possible with the expandable mold process. Part shapes in permanent mold process are limited by the need to open mold because we need to open the mold. Permanent mold processes are more economic in high production because we don't need to utilize time for making mold again and again. But also there is limitation of complex geometries in permanent mold. Sand casting mold terms. There are some terminologies we will discuss in next slide in detail, but I will tell you this is a downsprue. This area. This is basically the pouring cup. This is the pouring cup. Okay. This is the runner. This is the riser. This is basically the cast metal in cavity. That is the desired part. This is the cope, this is the drag, and this is the parting line, and this is core. So now we move on next slide. Sand casting terms. Mold consists of two halves. Basically there are upper and lower. Upper half is called cope and bottom half is called drag. This is cope and the lower one is drag. Mold halves are contained in a box called a flask. This is the flask, the metal one. The two halves separated by a parting line. This is the parting line. There is a pattern that is basically need for making the cavity, gating system, sprue, runner, pouring cup, and riser. Forming the mold cavity. How you made cavity in the mold. First of all, mold cavity is formed by packing sand around the pattern, which has the shape of the part. You need a mold. You put the pattern in it and put the sand on it. Press it, and then remove the cope. Remove the pattern and again place the core. Then this is the cavity is created. When pattern is removed, the remaining cavity has desired shape of the cast part. The pattern is usually oversized to allow for shrinkage. Sand for the mold is moist and contains a binder to maintain the shape. Uh, in sand there is a moisture and also binder that allows sand not to scatter. Cores in the mold cavity. The mold's cavity provide the external surfaces of the cast part. In addition, a casting may have internal surface determined by a core. If you need a hollow shape, you make the core of that desired shape, replace it, and then put the metal. After the solidification, the core is then removed from the desired part, placed inside the mold cavity to determine the core placed inside. And sand casting core are generally made of sand. Gating system is a channel through which the metal flows. It consists of a down sprue, simply sprue, also known as simply as just sprue, through which metals enter a runner leading to the main cavity. Atop of down sprue, there is a pouring cup that allows that reduce the turbulence, allow metal to go straightly. There is a riser. It is basically the reservoir, a tank that is providing metal when there is a need in the cavity, and it is made in a way that it solidifies later than the it solidifies later. The riser must be designed to freeze after the main casting in order to satisfy its function. In a sand mold, the air present in empty mold escapes through the natural porosity of sand mold. There is some air that is produced or some gas is produced in the mold that is evacuated by ventilating system, some of in the natural pores, and also small vent holes are drilled in the mold. Heating and pouring. First of all, heat the furnace and melt the metal. The heat is required is first of all to heat to rise temperature to the melting point. When we raise temperature to melting point, it starts melting, but not enough heat. Then plus add some heat of fusion to convert from solid to liquid. There is enough heat required to melt all total metal into the liquid. Plus add heat to raise molten metal to desired temperature for pouring. For example, all the metal melt at 1700 degrees centigrade, but there is some time for pouring and for traveling, so we must raise temperature to approximately 1850 so that it takes some time to solidify. This is the formula for heat freezing. H is equal to rho V. Rho is density. These are some constant: melting temperature, constants, fusion, heat of fusion, latent heat of blah blah. These are all the formula summing. The above analysis, however, normally leads to value of limit. So the above analysis, however, normally leads to a value of limited importance due to several errors. There are some errors that must include in it. There is an example. You have to solve it for your practice. Okay. 1 cubic meter of a certain eutectic alloy at room temperature 100 degrees centigrade and it's melting above its melting point. Density is 7.5, melting point is 800. So the pouring temperature is melting temperature 100 degrees more than melting point. So it is 900. Specific heat of metal is 0.33 in solid state and 0.29 in the liquid. Cs is this and Cl is this, and HF is equal to 160. How much heat is required to do the process, assuming no losses? So just putting the values in the given formula. Then pour the metal. For the first step successful, then factors allow all that the metal reaches in all the cavity. Factors are determined: pouring temperature, superheated temperature difference between pouring and freezing temperature, pouring rate, quick to achieve the full filling, and also turbulence. These are also examples, just like above one. Solidification of metal. Sorry. Transformation of molten metal back into solid state. Solidification differs depending on whether the metal is a pure element or an alloy. It depends. A pure metal solidifies at constant temperature, same as the melting point. Excuse me. Pouring temperature, liquid cooling graph, it is temperature time graph. Then freezing begins, again temperature falls. This is a straight relation. Solidification occur in a way. Due to chilled action of mold wall, the thin skin of solid metal is formed at interface immediately after pouring. There is that solidification near the walls is quick. Then rate of freezing depend upon heat transfer into the mold as well as thermal properties of metal. Gradually it comes, this wall become here and here, here and here, here and here. Most of alloys freeze over a temperature range rather than at a single temperature. These are the liquid cooling. Freezing begins because this is an alloy, so there is not the constant solidification. It's a gradual decrease in temperature and then solid cooling. This is for the alloy. There is solidification here also, but the other metal is not solidifying at that point. So there is different type of structures, grain structures. These are elongated, but these are not grain. This is granular structure. Solidification time is extracted from Schrödinger rules. TST is equal to Cm into V by A power n. V is the volume of the casting, A is surface area of the casting, N is exponent usually taken 2, and Cm is the mold constant. Mold constant in Schrödinger rules depends on mold material, thermal properties of casting metal, and also the pouring temperature relative to the melting point. What Schrödinger rules tell us? A casting with the higher volume to surface area ratio cools and solidifies more slowly than one with the slower ratio. If you have high ratio, then it solidify quickly. To feed molten metal to main cavity, TSD for riser must greater than TSD for main casting. This is the concept that we use in the riser making. We must increase the volume to surface area ratio to minimize the effect of shrinkages. What is shrinkage basically? Shrinkage is the starting level immediately after pouring. This is basically when we pour the metal. But after shrinkage, when the area of metal reduces, the level is decreased. This area is decreased. When the solidification occurs from this side, from this side, from this side, and also the reduction in height. But as solidification gradually increase, this is contracted metal. There is some spaces, shrinkage cavity. This is called the shrinkage cavity, which can also reduce the properties of metal. So the risers are made to minimize this concept. Solidification regularly occurs in nearly all metals because the solid phase has higher density, and then thus solidification causes a reduction in volume per unit length, per unit weight of metal, exception cast iron with high C content. Graphitization during final stages of freezing causes expansion that counteracts volumetric decrease associated with phase change. Shrinkage allowances also made battle makers account for solidification, shrinkage, and thermal contraction by making mold cavity oversized. Amount by which mold is made larger relatively to final casting is called pattern shrinkage allowance. Casting dimensions are expressed linearly, so allowances are applied accordingly. Directional solidification to minimize damaging effect of shrinkage. It is desirable for region of the casting most distant from the liquid metal supply to freeze first, and for solidification to process to remote regions toward riser. Desired direction solidification is achieved using Schrödinger rules. To design the casting itself, its orientation in the mold and the riser system that feed it. Chills, internal or external heat sinks that cause rapid freezing in certain regions of the casting. This is known as external chills. Just imagine that you don't put chills. It solidifies here, here, and here. Because the inner part solidifies later, so there is cavity. But when you replace external chills here, then this area also becomes solidified earlier. So when there is basically shrinkage, the metals from upside is come here, and the metal from reservoir is come here. Sorry for my reservoir. Riser is from riser come here. So it is again same thing that how to design riser. Riser is waste metal that is separated from the casting and remelted to make more casting. To minimize waste in unit operation, it is desirable for volume of metal in the riser to be minimum. and volume V by air ratio must be high. Riser can be open riser exposed to the outside or blind riser that is entirely closing the mold. This is an example. You have to do it for your practice, and best of luck. If you have any queries, if you didn't get my point, everyone has some mistakes. If you have to, if you noted my mistakes, tell me, I will improve it. And also sorry if there is any mistake. I will try my best to convey the exact message to you. Best of luck. See you in the next video. The next video is about casting. It is another chapter on casting, advance. So take care. Also like and subscribe my channel.